Okay. Hi guys. So I recorded the whole first one thinking I was being recorded on the webcam. Turns out my husband unplugged it. But now I can see myself down here, so that makes sense that I am now actually being recorded. Anyways, these things will get better as they go, I promise. So let's get into some of these practice problems, yeah? All right, so number one, an object is moving along a line such that its position function, s of t equals 2t cubed minus 21t squared plus 60t plus 3 for any t greater than or equal to 0, right? Because it wouldn't make sense to have negative time, right? And so the first one is find the velocity function and the acceleration function. So like we just went over, right? So to get, so we're going to start with position. And to get velocity, we're going to take the derivative. And then to get the acceleration, we'll take the derivative again. All right. So here we go. This is me trying to write. So, okay. So s of t, here we go. Yes. I'm writing with my mouse. Hopefully it turns out okay. So s of t was 2t squared minus 21t, that's an ugly t, it's okay, plus 60t and plus 3, right? All right, so the first one it asked me to find was, which one, velocity or acceleration? Good, velocity, right? So velocity is just take the derivative. So multiply forward. 2 times 2 is 4. Now t. Oh no, I forgot something. What the heck? You guys are probably like, you're wrong. That's a cubed right there. And that's a squared, huh? So, can I delete? There we go. Oh my gosh, it deleted. Okay, one more time. I'm really glad you guys are experiencing this with me. Okay. Otra vez. S of t equals 2t cubed minus 21t squared plus 60t plus 3. Okay. So when I take the velocity function, I just take the derivative of this. So 2 times 3 is 6, t to the now squared, minus 42 to now just a t, and then plus 60. Okay? And then acceleration is just take the derivative again. So 12t minus 42. Okay, and so then there's your velocity function and there's your acceleration function. Okay, so that's cool, right? Like it's calculus, but it's motion. And so these motion, position, velocity, and acceleration, they're all related based on calculus. So that's kind of cool. Okay. Hold on, it's not. Hold on. All right. Thank goodness for pause. And because that took me a lot longer than what it seemed. So anyways, part B here. So it says, what is V of 3? And then is the object moving to the right or left at t equals 3? So V of 3, back to like algebra, right? So we have our velocity function. And so we just plug in 3. So when we plug in 3, I'll give you guys a minute to do that. / maybe you could just press pause and do it. Okay, so when you plug in 3, we should get, oh, what just happened? Nothing. There we go. So we get negative 12. And so because our answer is negative, okay, then is the object moving to the right or left? Since it's negative, we know that it's moving to the left. Okay, it could also be moving down, but since the question asked right or left, we say left since it's negative. Okay. All right. Part C. What is a of 3? And then is the object speeding up or slowing down at t equals 3? So I'm going to give you a second. Go ahead and plug 3 into our acceleration function, which is the last function that we found. And we get, okay, I know you're ready. We get -6. Okay, hold on. I don't know if you guys can see that. There we go. Sorry. So you get -6. Okay. And then is it speeding up or slowing down? It's speeding up. Who remembers how we know whether it's speeding up or slowing down? Okay. So hopefully speeding up, right, is when both acceleration and velocity have the same sign. So it doesn't matter if it's positive, positive, or negative, negative. If it's the same sign, that wind is pushing in the direction that the vehicle is going or whatever the object is. And so it causes it to be speeding up. All right. I had this whole, like, when I was doing it before, I had this whole like hand blowing but you guys didn't get to see that because the webcam wasn't plugged in. So sorry about that. Hopefully you can just visualize it as I'm saying it. But anyway, so since at 3, the velocity was negative, and then at that same time, right, at 3, the acceleration is also negative. That's why it's speeding up. Okay, so you guys have a little bit of homework, slash just practice, you know. Oh no, just kidding. I have one more problem for you guys and then I have homework. So it says acceleration, a of t is 3t squared. And then it gives us some initial information, okay? And so what this stuff right here is going to do for us, remember how when I started with acceleration and I did the antiderivatives, I ended up with some constants, okay? These right here, these are going to help us get those constants, like know what they actually are and not leave them as a C, okay? So finding v of t, boo, let me draw it. Okay, so all right, so finding v of t, we're going to start with our acceleration and we're going to take the antiderivative, right? So we would add 1 and then divide by the new power. So v of t equals, 3 divided by 3 is just 1, so t cubed. And then, since it's an indefinite integral, we would put plus c. Okay, and so then we can actually use this to find what that c value is. Okay, so we're going to take this info and plug it in. And so v of 0 is 6. So I'm going to put that as my 6. Well, hold on. Okay, so v of 0 is going to be 6 equals, and it's of 0, right? So I plug the 0 in for t. So 0 cubed plus c. So c equals 6. Okay, and so then that, I plug it back into there. And so my final velocity, v of t, is t, oh, I don't know what just happened there. Erase. Back to my pen. T cubed plus 6. Okay, so that's my velocity. And then it asks me to find s of t. So I'm going to do that right here, and hopefully I'll make it not into my picture. So S of t is the antiderivative of v of t. Okay, so I'm going to add 1, t to the 4th, and divide by the new power. So I'm going to put a 1/4 plus 6t, right? Because it was a constant. And so I add 1 to that little invisible 0 power, and I get 6t. And it's indefinite, so I need my plus c. Okay? And so just like we did right here, I'm going to do the same thing with this s of 0 equals 3. So 3 equals 1/4 of 0 to the 4th. Yay, that ugliness is going to be 0. Plus 6 times 0 plus c. So that's 0, and so c equals 3. Oh my gosh, guys. That looks like a male genitalia. I'm horrible. 3 equals c. That looks better, yeah? I'm so glad we all experienced that together. Okay. I'm super red right now. Finishing that up. S of t equals 1/4 t to the 4th. Oh, that's not cute. It's okay. Plus 6t plus 3. And those are my two functions, and I use the antiderivative to get them. Okay? Yay! All right, so I want you guys to use the previous video and like the notes from there, and I want you guys to do the next few problems. Okay? So, oh, those are ugly. So go ahead and do it like on a second page. Yeah, online learning, super cute, right? Page 2, assignment A. So you're going to do 3 through 6. And so here's number 3. An object is moving along the x-axis. So that's just a number line. Such that its position function is x of t equals t times e to the t. So when you're finding velocity and acceleration, oh my goodness, you are going to have to use product rule, okay? Because you are finding the derivative of a function that is multiplying two functions, okay? So it's probably feeling like a little bit of 0 to 100, but it's not. We've gone over this. We've done this a bunch of times before, okay? So look back on your notes, whatever you need to do product rule, okay? T is your first function, e to the t is the second function, okay? Part B for that, what value of t is v of t equal to 0, okay? So this just means set the function, set your answer for v of t equal to 0, and then solve for t. Okay, you might need to use some factoring, some quadratic formula. I don't know. I'm going to let you guys try to figure that out. Okay, so set it equal to 0, set v of t equal to 0, and then solve for t. Okay. What does it mean for the velocity to be equal to 0? So this was something I answered in the notes. Okay. Number 4, an object is moving along the y-axis, so it's moving up and down. Okay, it's moving along the y-axis, such that its position function y of t equals t ln of t for t greater than or equal to 0. Find v of 2 and a of 2. So again, you're going to take this function and take its derivative to find v of t, and then the derivative again to find a of t. Don't forget to use product rule. Okay. And then once you have them, you just plug in 2 to get those answers. Number 5 tells us what acceleration is. So this is just like the second example I gave you. Okay, so it says find an expression for velocity and position in terms of time. And that just means find v of t and find s of t. Okay, so just like I did, and you're going to use these guys to not have the c's. No c's. Get numbers for them. Okay, and then for what value of t is v of t equal to 0? So this one is you got to take your velocity function when you have it and set it equal to 3 and solve for t, right? What value of t? That means solve for t. Okay, so set the whole thing equal to 3 and then solve for t. When something equals 3, you can't use like this times this equals 3, okay? You could only use factoring when it equals 0. Now you could make it equal 0 by subtracting the 3, by moving the 3, okay? But please, please, please don't ever tell me like this times this equals 3 and then set each of them equal to 3. It only works for zeros, okay? And the last problem, acceleration is t to the negative 3/2. Gave you some information here to use. Find v of t and y of t. Again, that's just position, okay? S of t, x of t, y of t, it's all the same, okay? And then in what direction is the object moving at t equals 9? Okay, so in what direction? Hopefully you know which one tells us about direction, right? So is it position, or is it velocity, or is it acceleration? So which one tells us about direction? Okay, and then I'm going to post this PowerPoint, and the answers are on the end. Well, let me just make it easy for you. I'll just, here are the answers. I think, I don't really know. I should have checked this first. I'll double check it and then let you guys know, okay? I love you. This was fun, I hope. Took about a half an hour. And yeah, so if you have any questions, we're going to have a Zoom meeting on Tuesday, which would be tomorrow. I'm totally doing this Sunday night. But yeah, so we'll Zoom meeting on Tuesday. And yeah, so if you have any questions, hit me up then. Send me a message on Remind. That's totally fine too. And yeah, hopefully you guys enjoyed this. I did. All right, bye. Oh, I can't pause it. Pause.